Okay, hello everyone at the Virtual Jug. Welcome to another Virtual Jug session, and this is going to be a functional tic-tac-toe speed run. So this is a heavy coding, no slides session. So get ready to geek out. And joining me is Richard. Hey Richard, how are you doing?
Hi there. I'm good, thanks.
Awesome, awesome. Now Richard, this is your first time on the VJug with us, right?
Yes, it is.
And this isn't the first, of course, this isn't the first time someone from Codurance has been on the Virtual Jug. I think we've had Sandro's definitely been on, and I'm not sure if anyone else has been on, but you're at least our second person from Codurance. So a big welcome to the Virtual Jug.
Cool, thanks. Really happy to be here.
What do you do then, Richard? You're a software craftsman?
That's right. I've been with Codurance about 9 months now. I've been programming for my living since 1998, so I've been around the block a few times, but I never got out of programming. I was never interested in management or being an architect or any of the other things that people tend to move away from programming towards.
And what is software craftsmanship? Or are you going to talk about it a little bit more in the session?
I, I, I wasn't specifically going to. So craftsmanship is not wanting to ship shit, basically, in a nutshell. Yeah, software craftspeople, they recognize that there's two audiences for your code, not only the machine that executes it, but also the person who has to look at your code after you, and they matter as well. And so when we code, then we always bear the person coming after us in mind.
Okay. So there's typically, would you say it's like a mix of software agile techniques, TDD, lean methodologies, that kind of thing?
Yeah, definitely. All of that. Software craftsmanship was born out of agile, but also in reaction to the way that agile was initially about software development methods. The manifesto talks about delivering software, but it kind of got co-opted by management consultants, and who have turned it into all about process and not about programming practices and techniques. And so craftsmanship was thought of as a name for what we do, people who do care about the doing the technical things well. And
Okay.
we think that agile basically doesn't work without these technical practices.
Okay, awesome. So I guess you're gonna be showing them today as you develop, maybe?
Yeah, I hope that will come across.
Excellent. So, to our virtual jug viewers, then, if you want to ask questions or interact, if you go to our Slack group, and if you actually go to our website virtualjug.com, there's a link to our Slack, both in the menu and actually beneath the video, and you can join on there. There's a live session channel. You can ask questions and chat through there. So, if any questions you do put there, if they're general questions, I'll leave them to the end. Otherwise, I'll interrupt Richard very politely, as we're both British, so we can do that nicely, and we'll go from there. It's going to be a 60-minute session in total, probably with questions. So we'll try aim to finish it around 6. And for those of you viewing live, there's a little settings cog at the bottom right. If you click on that and choose your highest resolution, you'll actually see the code in a nice kind of fuzz-free fashion. So make sure you set that up as well. Okay, so Richard, you work for Codurance. What does Codurance do?
Codurance is a software consultancy. It was formed by Sandro, who you mentioned, and his friend Mash. They formed the London software craftsmanship community back in 2010, and 4 years later, they formed Codurance. Because they had already set up one company on behalf of some Americans, and having been trusted to do that, they thought, well, if somebody else trusts us to form a company, then why don't we trust ourselves to do that? And so they started Codurance specifically with the craftsmanship ethos that was baked into the community. They wanted a company that was like the community. Sandro's vision is for Codurance to be seen as a thought leader in sort of software excellence.
Yeah, it's been going a few years as well now. I think it's about 4 or 5 years since well, from memory, from Codurance being created. So yeah, everyone's doing really well, and I'm pretty sure they're hiring like mad right now. So if anyone fancies getting in contact, please, or wants to work with Richard or Sandro, please reach out. I think there's a
Absolutely.
London, Barcelona, and I think maybe even a Manchester coming up soon as well. So lots of opportunities there. So without further ado, Richard, let me pass over to you, and you can share your screen and start the session.
Okay, my entire screen, and can you see that?
I can, yeah, perfect.
Okay, awesome. So everyone knows the tic-tac-toe game. It's righteously simple. There's no point people playing it, because as soon as you figure out, how never to lose, then no one ever wins a game. But it's an interesting programming kata, and we tend to use it quite often at Codurance when we're interviewing candidates. We just we'll give them some kata to do and sit down with them and watch them do it, and we choose this one quite often. And so I've watched a few people do it and seen the way they go about it. I've seen some people make a total hash of it. I've done it myself too. And so after a while, the thought occurred to me, well, what about how quickly could I do it properly? Because no one ever finishes it in an interview. We usually let them go for like an hour and a quarter or so, and then we cut it because we've sort of seen enough to come to a decision. And I thought, well, how quickly could you actually do it? And I thought, I bet I could do this in less than an hour. But also, how do I think I would like to do it? What's the right way to do it? And this is basically what I came up with. And I did it as a demonstration at one of Codurance's internal open space events, and it went down really well. People said that was cool. Can you record a screencast and put it on our website? So I did that, and that led to me being invited here, because Simon liked it and Sandro suggested I should do that. So without further ado, let's create a test. This is the Codurance naming style for our tests. I will add that to Git. We tend to name our tests something should, and then all of the individual test cases are meant to be read following on from that. So it's game should do this, game should do that. I will just make use of the display name feature in JUnit 5 just because it's nice. So the game adjudicator should. That's what we're writing here. We're writing a program which knows the rules of tic-tac-toe and can judge between two people playing it. It's going to present a simple API, but there's no user interface or anything like that. So it's a library. Now, most people start off by thinking, well, it's a 3x3 grid, so that's a two-dimensional array, and they start thinking along these kind of terms. But is that actually the simplest thing? The simplest thing is more likely to be who plays first. X plays first, and after X has played, O must play, and then they alternate. So why don't we start there? So a game should wait for X to play first. So I will start with a game. I'll create that. And there's one thing I've forgotten to do.
So is this Java version 10 or 11?
This is 10. And it's not very widely used yet. Not everything works nicely with it. I'm sure in time it will become the standard. But
have you had any problems with like this kind of a simpler demo, or is it fairly well working on a simple demo?
on demonstrations, it's fine. It's when you start working on real stuff that you start to find things that aren't compatible. So we've got a game, and I want the game to tell me what the state of things is. So that game state is equal to new game state, and it is going to be game on, and it's waiting for player X. I have to create a few things. First of all, I will create this enum. And that constant. And I'll create the player. And this object. Status. No. Player is the next player. Get some fields for those. There's a fair amount to do before you get going, but we're nearly there. Create a method. That's supposed to be a game state. I don't know why it didn't infer that correctly. And we put that on one line. Yes, we can. Okay. So actual null, that's perfectly reasonable. So let's begin just by hard coding a new state. And now it's not crashing, but okay, that's not telling us very much. So let's help ourselves out by adding an equals method. And that's green. I'm just going to add a toString as well, because this will help. Okay. I'm just going to do that to help things. So is that not working? Okay. So that's fine. So after X has played, O should play. So that would be our next test. And I will first of all just commit that. This is live. I might screw up. And if I do, I'd like to have a good state to go back to, fairly recent. So here we are. So the next test. Wait for O to play after X. So here was another thing. I wanted to, every time you play, to get back an object which represents the new state of the game, so it's impossible for me to do the wrong thing with it. It just won't let me. So that means that I will do something like this and borrow the assertion. Now it should be to play next. Okay. Null pointer exception. And of course it is. So we'll return a new game, and it's going to be to play next. So let's create that constructor. Next player. Generate field for it. But I'm going to have to add a no argument constructor as well. And I will initialize that. And I can make that constructor private because I don't want anybody to call that. I want everybody to call this. And now I should be able to replace that. Nope, I have broken something. And that's because initially it needs to be X. Okay, cool. So far so good. I will just import that. All right. That's pretty simple. Too simple. We need the players to alternate, so let's do that. So game should alternate the players. So this is very similar to this one. We'll just do that one more time, and now it should be X again. Now we've got to do something a bit more sophisticated. So to do this, I'm going to repurpose this field. I don't want this to be next player. I want it to be current player instead. You can have it as next player. To be honest, it gets a little bit fiddly somewhere, no matter which way you have it. I've found through practice it's slightly easier to do it this way. And yes, that's right. So I will initialize the current player to null.
Well, why would you initialize it to null when that's going to be kind of null to start off with anyway when it's created?
Because it's final, and the compiler
okay,
says you have to initialize it to something.
Got it.
And I will give myself a method. No. I did the wrong. Did I do the wrong thing? No, that's right. That's where I've gone wrong. Yes, it is. Okay.
A quick question about that actually in Slack. Sri asks why we create a new game every time on play. Would that not restart the game every time?
No, it doesn't. So if I go to the test, then this particular instance is the game before anybody has played. And what we do here is then we have created a new instance on the first play, but the original instance still exists. So actually we have 3 instances of the game created here.
Okay.
So that's kind of the point, actually, of functional programming, is that wherever possible, you don't change the state of things. You create the appearance of state change by actually creating new things. In Java, a good example is strings. String is central to the whole language, and strings are all immutable. So if you concatenate 2 strings together, then what you actually get is a brand new string, which is equal to the concatenation. But the original 2 strings are still there. And anything that holds a reference to them will not see any change. Similarly, if this game instance, if some other part of the program held a reference to this game instance, it would never see any change. This would always represent the game at the beginning, before anybody had played.
Mm-hmm. Cool.
I'll do something cool with this in a bit, but we're not quite ready for that yet. So I think the tests are passing. Yes, they are. So I will commit this. Actually, before I commit it, I think I will remove this test because the next test has made it largely redundant. Alternating the players is the behavior we really wanted, but the test I wrote before that was a stepping stone towards getting where I wanted to get to. So alternate the players. Okay, fine. So that is about all we can do in terms of sequencing. Now we have to start thinking about squares, positions. But to do TDD, whatever you do, it has to be falsifiable. So I can't just go and plug squares into here because I need something to assert on. So I know that what I've done has worked. So the simplest thing I can think of is to check that the game should not allow a square to be played twice. So let's do that. So now we are going to have to actually create this concept. So let's do that. And now I have to add that parameter to the play method. And it's helpfully added it in here as well. Although I don't want that here. So I'm going to have to create another constant because I don't want this test to fail for the same reason. So now it should be Y to play because X was playing, X played there, that meant Y is playing next. Y tried to play the same, no, not Y, O. I always make this mistake. So it's still O to play because they tried to play an invalid move. And I will also create a status for that. Okay. So now I'm going to have to introduce something that represents the board, the playing space, whatever you want to call it. So the play method, this is where we should check if then, and we're going to have to tell the game now what the status is supposed to be. And we're not going to advance the player because it's stay the same. Otherwise. And that is going to be game on. So I don't want to add it to that constructor. I want to add it to that one. Thank you. And I'll import that and reformat. And up here, let's change that to the status. And I'm actually going to have to also pass the board to each game as well. Not there. I'm going to and we'll create that field. It's not a player, it's a board. Create that class. And it's actually going in the right place this time. And we have to add that to the constructor as well. I'm going to change that to our already taken actually, because I've got take there. It's good to be consistent. Goes to fields, and I will make that final because it will force me to initialize it. And the same for this guy. So the status is initially game on. We've got a new board. The current player is nobody. And then thereafter, every time we play, then we create a new game. We tell it what the status is. We tell it what its board looks like. And we tell it who's up next. Or who's just played, actually. We've got to create a couple of methods in here. So what do we do with this? Let's do the simplest thing we can. This has to return a new board because we're trying to be functional. So we don't want to mutate any state if we can avoid it. And here we can easily avoid it. So that requires a constructor. We'll call that the taken square. And create a field for that. Fine. But once again, we'll need a no argument constructor. We'll make this one private because it's only for our own use. Now we can do something about this. That's dead simple. Is it the same? Run the tests. And what have we got? So we're expecting that status, but that's not what we've got. So let's have a look, see why. Well, might have something to do with this. Ah, there we go. So do not permit square to be played twice. Part 1. Why part 1? Well, you will have noticed that this board is ridiculously simple. But we're doing TDD, so we've got to tease this out with a test. So let's modify this test, because that also should return square already played, although it should jog the player on because there's one extra move. And if we run that, then Now, it's allowed it, and it shouldn't have. So let's make it do that. And that's fairly simple. We just turn this scalar value into a vector set, because that seems reasonable. And I'm going to make its name plural. And not much needs to change. We need to change that type to match. And we just do contains. And here we will create a local variable, new hash set of squares containing the ones that have already been taken. So this is the only place where I'm actually mutating state, because it is possible to create a set from another set by messing around with streams, but frankly, it's not worth it. Especially later on, it becomes very awkward. So it's simpler to do this, although I do seem to have broken it, board already token, and that's because I need to initialize that. Yes, there's a sweet spot for functional programming in most languages. Java is no exception, and this is not it. In a proper functional language, then you can easily create a collection out of an existing collection plus one more thing, and that's just a bread and butter operation in the language. Java's not like that. You can sort of do it, but it's not worth it. You might as well just create a new set and add something to it. However, I will var it because I can. Well, there's something weird. It's telling me that you don't need that, although actually you do, because it can't infer it. So I'm not quite sure why it's telling me that you don't need it. Anyway, that's good. So I'll commit where we're up to. That's part 2. Now go back to our test. So we've not allowed a square to be played twice. So what's next? Well, probably testing for a draw, because that's quite simple. So the game should recognize a draw. So this means the board has been completely filled, no one's got a line. So I have to actually construct a scenario that looks like that. So I will just that is a full game and no one has won, I believe.
I think X has won that one, though.
Oh yes, you're right. What I need to change here. I don't have enough O's actually, that's the problem. I've got 5 X's, 4 O's, that's correct.
Yeah.
Nice, thank you. So let us do a thing. But before I do that, I said I could do something with this gameplay. So I'll do that, because that's very quick and it shows a functional programming technique as well. Imagine I create a method, but instead of that signature, I give it a varargs. I can do this. I can stream the squares and then reduce them. So reducing, for people that don't know, is where you take a collection of things and you accumulate them down to a single result. The obvious example is summing a list of numbers, but it doesn't have to be numbers because we can do this instead. We have to give reduce 3 arguments. The first is the seed value, which is a new game. Then we have to give it an accumulator function, which is a, and then we have to give it a combiner function, which actually, for our purposes, can be anything at all. And I will explain that after I've seen that it works, which it does. The reason for this weirdness is because their streams can be processed in parallel. That's part of the point. And the designers of the API wanted the same API, whether you were doing a parallel stream or not, and we're not. But when you're reducing, then what we're doing here is we're reducing a stream of squares down into a game. So that's a different type. And if we were doing the stream in a parallel operation, then the stream would be broken up into chunks, and each chunk would be reduced down to an interim result, and then all those interim results would need to be combined to the final result. And that's what this argument here is meant to do, because we're going to reduce squares down into a game, and then we'd end up with a bunch of games that we somehow have to combine into a final game. For us, that doesn't make any sense because the game has to be played in sequence. It doesn't make any sense. And because it's not a parallel stream, this lambda never gets invoked. So I could make it return A, and that will work. I could make it return B, and that will work. I could make it throw an exception, and that wouldn't matter either because it's never going to call it. So that's unfortunate, but it's still nice to show. And now I've done that, then I can use it in this test. So I can say var game equals play, and then we'll play all these positions. So that will be top left for X, and then top middle for O, and then top right for X, and center left for O, center middle, and then bottom left for X, and center right for O, and bottom middle for X, and bottom right for O, and I think that is correct. And I'm going to have to create all of those. Import all of those. Thank you very much. Right, assert that game state is equal to going to be a draw. Spell it right. And next player is going to be nobody. So I'll create a value to represent that. As a draw, now it fails because it doesn't know any better. Let's make it know better. So in here, when we create a new game, then we know there is room on the board because play won't allow. Actually, I'm jumping ahead of myself here. So we need to check. So we can create that method. This is dead simple. And what's wrong here? So it's recognized a draw, but it thinks somebody is up to play next. That is because we need and there we go. It can tell when the game is stalemated. Okay, so that's starting to fill out the functionality a bit. Now there's nothing for it but to start thinking about winning. But I've done everything that I can think of before doing that, and this is called not reaching for the gold too soon. Testing a winning condition, that's the gold. And quite often in TDD, it's very helpful to test as many things around the main functionality as you can, because it often actually helps, and it does help here. Because now we'll dive in and we'll see that it's not as difficult as you might think. So the game should recognize when X has 1. And this is going to be a parameterized test because there is a number of different combinations that win. 8, in fact. And we're going to do them all. Let's start with 1. So let's imagine X plays in top left and O plays in center left directly below it, and then X plays in top middle and O plays in center middle and X plays in top right. Two, three, four, 5. Now we can just do var game equals play S1, S2, S3, S4, S5. And X is 1. And to play, nobody, because the game's over. Okay. And it doesn't know anything about winning, so let's make it no. So else if board has 1, and we're not actually dealing with who's won yet. So the reason I named the test recognize when X has 1 is simply because the fastest way for somebody to win is for X to win, because they can do it in 5 moves. Status X has 1. We need to implement this method. So how do we do this? Stream of the winning combination that we're testing. So that's squares along the top. And all of those need to match. And that's failing. Why is it failing? Well, it's recognized the win, but that's wrong. And that's because of this. There you go. So that's actually not that hard. Obviously, there's more scenarios. So let's try another one. Let's just reverse that. So let's go through the middle. So X plays in center left and O plays in top left, and center middle and top middle and center right. Now we've got two possible winning combinations. And we have to, so that is a winning combo. And we want all of them. So that's one. Center left, center middle, center right. This is another one. And then we want to with that. So all of the winning combos, stream them. And this time, any of them match. And I don't need to stream that because it is a stream. That's what the problem was. So basically, any of these, if any of them match this predicate, which is saying that all of these have to be contained within this taken squares. It's a bit of a mouthful, but it works. And we can do that. Now, I'm afraid there's nothing for it but to take a deep breath and implement them all. It doesn't take that long, so let's get on with it. Bottom left, top left, bottom middle, top middle, bottom right. And okay, and then we're going to win down the left. So that'll be top left, top middle, center left, middle, bottom left. Halfway there. So reverse that, be winning down the middle, top left, center middle, center left, bottom middle. Cool. That'll be top right next, top left, center right, center left, and bottom right. I'm so glad my typing is behaving itself reasonably today. And add that combo. Okay, just the diagonals to go. So say top left, bottom left, center middle, top right, and bottom right, that should be.
Is it a best practice in TDD to always only write one test at a time, or?
I prefer it.
Yeah.
The reason I prefer it is that if I screw any of these up, then I want to know where as soon as possible, because otherwise it's a bit tricky to debug where I've gone wrong. I wouldn't bother actually committing on every one of these, but yes, I feel kind of naked when I don't have a fast unit test suite now, because I habitually run the tests all the time just to get some feedback. And yes, I like to do the smallest amount of programming I can in order to get some kind of result. You know the Uncle Bob's 3 laws of TDD?
I don't know. Go on.
Okay, the first law is that you may write no production code without a failing test first, which is simple enough. But then the second law is that you may write no more of your test than is necessary to demonstrate a failure. And if it doesn't compile, that counts as a failure. So what this means is that you start writing test, and as soon as something in your IDE is in red, then you have to go and fix that. Which may be creating a class, creating a method, creating a constant, anything. You have to fix that before you can go back to your test and then carry on writing, ultimately until you can get to an assertion that fails. And then the third law is that you may write no more production code than is necessary to make your test go green. And I really internalized these when I learned how to do TDD, and so that's the way I do it. Sandro is much more relaxed about this. He's quite happy to write a load of test code with red everywhere. He prefers to just get the idea out first, and he typically starts with the assertion. And he's quite relaxed about having red text on his screen.
For me, I'm actually the other way. When I'm watching you code, it's quite interesting actually, because I see you coding a little bit just to get enough for the test to pass. But I'd be too tempted just to write that little bit more code, because I know I'm going to need to do something in the in future. So I want to continue coding, but I guess that's my old habits, right?
Yeah, probably.
Interestingly, Filippo has just started a poll in live session asking how many people use TDD in their daily work, and he's got crosses for no's and the kind of rock symbol for yes. But this was a perfect opportunity to use noughts and crosses as votes, but unfortunately, Filippo didn't do it.
So while we've been talking, I've just put in the last combo, so that's it. We're testing winning now for one player at least. So recognize the win for X. So that's cool. We're getting quite some way in now. So that's for X, but what about O? We don't need to test all the combos. All we need to do is just create one game that O is winning in. So then O has won. And so let's just take one of these and we can convert it into a win for O just by adding another play on the head of it, because then that means that X has gone there and O has gone top left and top middle and top right. So O should be winning that. Let's and I don't believe we have a status for that yet. No, we don't. And indeed, it has probably erroneously awarded it to X, and so it has. So now we need to first of all, when we play, then we need to actually now tell the board who is taking that place on the board. So we'll add that. And then when we inquire from the board whether the winning combination, we actually need to say who we're talking about. And now on the board, our set needs to turn into a map. And if you're groaning and thinking, God, that sounds like a lot of work, it's actually not that much. So we need a map mapping the squares to the players. This just changes to hash map. And this just needs to change to match the correct signature. And this is dead simple. So the taken squares, we just get the key set out, and then that works the same way. This needs to, thank you. That's new. I haven't seen that before. So this now needs to be a new hash map, and we need to put, and that needs to change. So we need to say squares taken by current player, and we'll create a method for that. So that's going to return a set of squares. So here we go. We just taken squares, get the entry set, stream all of those, and then we want to filter out all of the ones where the value, which is the square, no, which is the player, matches where we want, and then we map it to get the square, which is the key, and we collect those to a set, and Bob's your uncle. What's wrong with that? Interesting. I'll come back to that. So that's what I was expecting. So I'll fix that first. And the reason for that is because so when we know somebody's won, but we have to actually do something about that. We have to say, okay, well, it's X, X has won, and if it's O, then it's O has won. And it's still failing on both those tests. That I know the reason for, and that's because here we need to add that O has won. Right. And what's gone wrong here? So that's the top right, bottom right, center middle. So that is supposed to be top right is twice in there. That's wrong. Let's try changing that to top left.
See, this is when I was talking to you, see.
That's okay. Yep, that's good. There you go, live debugging. A win for O. Okay, so we're pretty close to complete now. There's a couple of bugs in here, which we should tease out. So first thing, it should not permit play after the game has been won. So we'll just borrow that game again. We know X wins that. and we don't want this to be allowed. So if I were to go, then that would apparently give O a win, which shouldn't be allowed. And there's no way I'm updating you yet. Okay. And as I said, it's gone and awarded the win to O, which is wrong. So let's do something about that. So it's in the play method. Basically, we want to prevent the play if the game is either drawn or won. And well, we've actually got that condition here. So let's just extract a method, and we'll call that game is over, because that's basically what that means. And we can say if the game is over, then just return the current instance. So on a game that's been won, you can't do anything to it now. And if we run this, okay. So let's just not permit play after game is won. And we are almost out of time, but there's just one more thing. There is a bug in here, and I don't know if you've noticed it, but I'll tease it out with a test. So should recognize win when won on final square. So let's just create a game. So if we do that, it will be top left and top middle and top right for X and center left for O and center middle for X, and then bottom left for O, center right for X, bottom middle for O, finally bottom right for X, and that should be a win for X. Oh no, what's it done? What it's done, it's gone and called it a draw instead, because the board is full. And the reason for that is because I'm doing things in the wrong order. So this needs to be moved up there. And what have I done? Okay, I've broken that, but we're out of time, so I think Simon needs to get off.
Actually, we're good for a couple more minutes if you want to fix.
Okay, see if I can find what the problem is. So it's saying that X is 1. What's the test do? Top left is X, and top middle is O, top right X, center left is O, center middle is X, bottom left is O.
That should be bottom middle. No, bottom right.
Ah, these are in the wrong order. Is that what it is? Yeah, there you go. That was it. Sweet.
Awesome. Well, thank you very much, Richard. That was really good. We've had some good discussion actually in the channel as well, both about Slack polls and about TDD. So it's good to Good to read up on that. Thank you very much. Any additional reading material for people who? I mean, there's two parts here really. There's functional that you've shown, and there's also the kind of a good TDD practice. Would you recommend maybe one of Uncle Bob's books or something else for TDD practice?
I don't know any books for TDD per se. Uncle Bob, the best book I would recommend is Clean Code. Because there's that book definitely opened my eyes and changed the way I approached coding. But it's regarding TDD, I've never seen any good book on that.
Interesting.
And I learnt it from people rather than books.
The authors are still writing the tests for that one, huh?
Yes.
And Sandro wrote a book as well, right, about software craftsmanship. That seems to be a pretty good book.
Yes, he did. That was actually what inspired me to apply for a job, because it's very similar in ways to Bob's book, the Clean Coder, in that it's a book about behaviors rather than coding techniques. You know, sort of how a professional software developer behaves, and how they go about growing their career. But yeah, so that's a good book. I recommend it, and it gives you a really good insight into what Codurance is about.
Okay, awesome. There's also actually a book recommendation from, who was it? Let me find. Here it is, N. Widart, saying cleancoders.com is perhaps a good place as well for some related videos on TDD as well. One final question: are you pushing the code for this session?
Yes.
Was the code available as well?
So let us do that. I think actually all I have to do is just push. And I will share that on Slack with you.
Perfect. Thank you very much. Awesome, Richard. Thank you very much for your session. And just before we go, there is another session which has very kindly been put up on the VJug site from Elena. So I'm just grabbing that up now. This one is a session around Kafka, I believe. Just trying to find it. See, oh, there we go. Here we go. So Kafka, a streaming data platform, and this is a session from a friend, Victor Gamoff, who works for Confluent. So that session is going to be on August the 7th, Tuesday, August the 7th, hosted by Oleg. So do make sure you RSVP to that. In fact, let me just announce that right now. So emails going out about that right now. So feel free to RSVP there. Awesome. Thank you very much, Richard. Appreciate your time, and feel free to drop into Slack for any additional questions through there.
Sure. Thanks for having me. It's been a lot of fun.
Our pleasure. Thank you. Bye now.
Cheers.